3L minus 6 is greater than or equal to 8. Which of the following best describes the solutions to the inequality shown above? So it's 3 times L minus 6 is greater than or equal to 8. Well, all of these choices, these are in terms of L. They've said L on one side and is greater than or equal to. Actually, all of these choices are greater than or equal to something else. So let's see what we can do to get just an L on the left-hand side. So the first thing we might want to do is let's get rid of this subtracting a 6. And the best way we can do that is we can add 6. Let's add 6 to both sides. This 6 and this 6 are going to add to 0. And then we are going to be left with 3L on the left-hand side is greater than or equal to 8 plus 6 is 14. Now, just got an L on the left-hand side, we can divide both sides by 3. And if you divide both sides by 3, you're not going to change the sign. You're not going to change the inequality. If you're dividing by a negative number, you would swap the inequality. Greater than or equal to would turn to less than or equal to. But we're dividing by a positive number. So this is going to be L is greater than or equal to 14 over 3, which is that choice right there. In the equation shown above, A is a constant. For what value of A does the equation have infinitely many solutions? So you end up with infinitely many solutions if your equation simplifies to something like x is equal to x or 1 is equal to 1. Something that's true, that's going to be true for any x that you pick. So let's see what we could do with this thing right over here. And these are obviously not, if you got 100 equals 100, that would be the same, that would have an infinitely many solutions. 0 equals 0. These will all be situations where you have an infinite number of solutions. So when I look at this thing up here, my first instinct is, well, let's just see if I can simplify this a little bit. I'll leave the A in there and then see if I can get to a point where it's going to have an infinite number of solutions. So let me just rewrite it. So we're going to have 3 plus 10x minus 5 is equal to A plus 1 times x minus 2. So let's see, on the left hand here, I can add the 3 and the negative 5, or I could take 3 minus 5. That would be negative 2. So I get 10x minus 2 is equal to, let me distribute the x. So it's going to be ax plus x. All I did here is I distributed the x minus 2. Now let's see, what happens if, I could get rid of both of these negative 2's if I add 2 to both sides. So if I just, remember, anything I do to one side, I've got to do to the other one if I want to hold the equality to continue to be true. So I just added 2 to both sides, and I am left with 10x is equal to ax plus x. Let's see, let's subtract x from both sides. So if I subtract x, actually I can write it like this. I could subtract x from both sides. On the left-hand side, I'm going to get 9x. On the right-hand side, I'm going to get ax. So how could I have an infinite number of solutions, an equation that's going to be true for any x? Well, if a was equal to 9, because if a is equal to 9, I'm going to have a situation. So if a is equal to 9, then you're going to have a situation where 9x is going to be equal to, instead of a, I'd write 9, is going to be equal to 9x. Well, that's going to be true for any x. Any x times 9 is going to be equal to that same x times 9 again. You're going to have an infinite number of solutions. And so it needs to be equal to, a is equal to 9. Now, what's really interesting here is think about what would happen if a is any of these other things right over here. Then you're going to force a different solution. But anyway, we'll leave that for another video. The amount of money that farmers in Massachusetts paid to maintain their crops between 1991 and 2008 is modeled by the equation above, where P is the amount of money the farmers paid in millions of dollars and T is the year. So this is how much they paid in millions of dollars. T is the year, but they're saying assuming 1991 is T equals 0. What does a 3.53 mean in the equation? So let's look at this. So at T, in 1991, when T is equal to 0, this whole term is going to be equal to 0. And the farmers are going to pay, P is going to be 100. So they're going to pay $100 million in 1991 to maintain their crops. These are all the farmers in Massachusetts. Now, as t increments, each time t increases by 1, the amount that the farmers pay is going to increase by 3.53 times 1. So one way to think about it is this is the rate of increase from year to year. As t goes up a year, the amount the farmers pay is going to increase by $3.53 million. So let's see which of these choices are consistent with what I just said. All right. The cost for maintaining crops was $3.53 million in 1991. No, that's just not true. In 1991, this term is zero and it was $100 million. The cost for maintaining crops was $3.53 million in 2008. No, that's not going to be true either because it's $100 million in 1991 and then each year it's going to increase by $3.53 million. The cost for maintaining crops increased a total of $3.53 million between 1991 and 2008. No, it's going to increase $3.53 million per year, not over the entire time span. The cost for maintaining crops increased by $3.53 million each year between 1991 and 2008. That is exactly right. Every time t, and we go forward a year, t increases by 1, it's going to increase. We're going to have 3.53 times that one higher t, so we're going to increase the whole p by 3.53. That kind of rhymed. Alice fills up the gas tank of her car before going for a long drive. The equation below, it should be above, the equation above models the amount of gas, G, in gallons in Alice's car when she has driven m miles. What is the meaning of 32 in the equation? All right, let's look up here. This is the gallons that she has left in her car. And what's going on here? So it makes sense that, look, when m is 0, when she's driven nothing, she's going to have 15 gallons in her car. And then as you drive more and more, you're going to subtract more and more gallons from her car. So this term right over here. This is the number of gallons. This is the number of gallons used up. So why are you dividing? If you have m miles divided by 32, how do you get gallons? What do the units on the 32 need to be? And so let's just think about this. If I have miles, so this is miles up here, and I'm going to be dividing them by some mystery units. I need to get gallons. I need to get gallons because this is going to be the number of gallons used up. So what are the mystery units going to be? Well, we can treat these units the way we would treat algebraic variables. So we could solve for units here. So we could take the reciprocal of both sides and we could say the mystery units divided by miles is going to be 1 over gallons, or I guess you say per gallon. It's going to be 1 over gallons. And then multiply both sides times miles. You're going to get the mystery units. The mystery units are going to be, if you multiply both sides by miles, I don't want to get confused with this over here. So we multiply both sides by miles. Your mystery units are going to be miles per gallon. So this right over here, the units over here, in order for this thing to come out to miles, or in order to come out to gallons, in the numerator you have m miles divided by 32 miles per gallon. This is telling you how much mileage you get per gallon for her car, how much she is getting. So let's get the choices. Alice uses 32 gallons of gas per mile. We have to be very careful. It's miles per gallon, not gas per mile. Alice's tank can hold 32 gallons of gas. No, Alice's tank can hold 15 gallons of gas. She fills up her tank, and before she's driven anything, we see here when m is 0, she's going to have 15 gallons in her car. So that's not right. Alice can drive 32 miles on a tank of gas. That's right. The units here are 32 miles per gallon. So that's that one. Alice's car can drive 32 miles to the gallon. Oh, that was a close one. This isn't 32 miles per gallon. This is 32 miles on a tank of gas. This would be 32 miles on over 15 gallons. No, that's not right. That was a close one. Alice's car can drive 32 miles per gallon. That's right. 32 miles per gallon. And if this unit business that I just did, you find it confusing, one other way to think about it, I mean, you could have ruled out something like this, because when you look at this, you could see that, okay, her tank holds 32, her tank holds 15 gallons. Is you could have tried this one, and you would have seen that the units didn't work out. If you have 15 gallons minus m miles divided by 32 gallons per mile, 32 gallons per mile, what will the units end up being here? Especially right over here. You would have miles divided by gallons per mile. This is going to be minus m times, I guess let me write it this way, m over 32 miles times miles per gallon. Miles per gallon, you get miles squared per gallon. You get these crazy units up here. So hopefully it makes sense that we would pick this last choice. And this one almost got me when they said tank of gas. My brain was thinking gallon. I was so already programmed for the answer. But anyway, yes, this is the last choice is what we want to go with. Kaylee wants to do well in her classes, so she is budgeting her time carefully to decide the number of classes C she will take this year. For each class that she takes, she expects to spend 2.5 hours each week working on homework. She expects to spend an additional 6.5 hours each week completing the assigned reading for all of her classes together. If Kaylee has 19 hours available each week to complete homework and reading for her classes, which equation best models the situation? All right, so she has a total of 19 hours available. She has 19 hours available, and she has 19 hours available each week to complete homework and reading for her classes. So how much time is it going to take her to complete the homework? Well, it says that she expects to spend 2.5 hours each week working on homework for each class that she takes. She expects to spend 2.5 hours each week working on homework. Let me underline that. For each class that she takes, she expects to spend 2.5 hours each week working on homework. So it's going to be 2.5 hours each week per class. Now, how many classes is she taking? Well, she's going to take C classes. So the total amount that she spends on homework, is going to be 2.5 times C. I'll put in parentheses just to make it clear what I'm doing here. So it's going to be 2.5 times C is the amount she spends on homework. And how much is she going to spend on reading? Well, it says over here, she expects to spend an additional 6.5 hours each week completing the assigned reading for all of her classes together. So this sentence says it doesn't matter how many classes she takes, she's going to spend 6.5 hours reading. So it's not dependent on the number of classes she takes. So this is the amount of time she's just going to spend reading. And so the amount she spends on homework plus the amount she spends on reading need to add up to 19 hours. So which of these choices are what I just wrote over here? So let's see. They have the 19 on the other side, but let's see. They have 2.5 C minus 6.5. No, that's not this right over here. 2.5 C plus 6.5. Yep, that's what we have over here, is equal to 19. Yep, that's this choice. The only difference between this and what I wrote is they just swapped the two sides of the equality, which you can always do. These other choices, let's see, 6.5 times C. Well, this would imply that you're spending 6.5 hours per class, so that's not right. And then this is also 6.5 times C, so that's not going to work out either. We're told in 2017, Celeste's income tax was $2,290. Her income tax rate was 10% for the first $13,000 of her income and 15% for her income in excess of $13,000. Which of the following equations best models X, Celeste's income in dollars in 2017? So pause this video and see if you can work through this. All right, now let's do it together. And rather than going choice by choice, I would just like to construct an expression that involves her income, X, and then gets us to what her taxes should be, and then equates that to $2,290. So they tell us that the first 13, or her income tax rate was 10% for the first $13,000 of her income. So one way to do that, we could say that would be 10% times 13,000. So I could write it like that, maybe. So that's going to be her first 13,000. And then it says 15% for her income in excess of $13,000. So it's going to be plus 15% times her income in excess of $13,000. Well, how could we express that? Well, her income in excess of $13,000 would be X minus $13,000. And that all of that, would be her total income tax. All of that should be equal to $2,290, $2,290. Okay, let's see which of these choices describe that. All right, this one is adding the income tax rates and then multiplying it times X. So it's really charging 25% of all the taxes, then subtracting out $13,000. No, that is not going to be the same as that. Let's see, this is 15% of her total income, and then 10% on the 13,000. No, because this isn't the 15% on the excess above 13,000. Rule that out. This is 10% on the first 13,000. And so this and this are definitely equivalent. And then 15% on her total income. No, it should be on the excess. So this one is not right. Rule this one out. Let's hope this one works. So 10% of the first 13,000, that's equivalent to that, plus 15% of the excess. So that is equivalent to this, and that should be equal to $2,290. So I like that choice. A convenience store requires that a Yumi spend $4 or more if she wants to pay using a debit card. Donuts each cost 80 cents. Donuts each cost 80 cents, or 80 cents each. A bottle of orange juice costs $1.20. If D represents the number of donuts a Yumi would need to pay for one orange juice and the donuts using a debit card, which of the following inequalities best models the situation described above? All right, so she needs to spend $4 or more, and she's going to buy one orange juice. She's going to buy one orange juice and D donuts. D represents the number of donuts. So let's write this down. So this one orange juice right over there, that's going to be $1.20. We'll assume everything I'm writing is in dollars. That's that. And then how much is she going to spend on donuts? Well, the donuts are 80 cents each, and D is the number of donuts. So she's going to spend 80 cents times D, or 0.80D. We could write it like that, or we could just write this as 0.8D. So this is what she's spending on that one orange juice. This is what she's spending on the D donuts. And in order to use her debit card, she needs to spend $4 or more. So this thing right over here needs to be greater than or equal to $4. Once again, greater than $4, that's the or more, but it could also be exactly $4, and that's why we have the equal sign right over here. So let's see, which of these choices describe that? Let's see, if 0.8D plus 1.2 is greater than 4. So before you even see if this expression right over here is equivalent to this expression right over here, you can see this is greater than 4. We want to be greater than or equal to 4. But so just like that, you could rule this one out. And actually, if you distribute the 0.8D, you will see that you get something different. You get 0.8D, and then 0.8 times 1.2 is not $1.20, is not $1.2 right over here. So we can rule that one out. 0.8D plus 0.8 times D plus 1.2 is greater than or equal to 4. Well, let's see, that has a greater than or equal to, but if you distribute 0.8D, 0.8 times D is going to be this, but 0.8 times 1.2 is not 1.2. It's going to be 0.96, 0.96. So that's not going to work out. Let's see, 0.8D plus 1.2 is greater than 4. We're close, but remember, we want greater than or equal to 4. And then lucky for us, this right over here is very similar. It's exactly what we wrote up here, with just the difference that instead of writing $1.20, they wrote 1.2. So if you just swap these two around, you get 0, we do it in those same colors. You get 0.8D plus, instead of writing $1.20, I'll just write 1.2 is greater than or equal to 4. Is greater than or equal to 4. So this is exactly what we had over there. So I would definitely feel good about picking this one. Now, if you're doing this in really kind of timed conditions, I would, instead of even doing this, you could go straight, instead of just even trying to think it through, you could go straight to say, well, which of these really describes what's going on here? So let's see, we want to be greater than or equal to $4. We're going to spend $1.20 on orange juice, and then the amount that we spent on donuts is that right over there. So you might have been able to just cut to the chase and pick that one, whichever way works better for you. Ngozi, I think that's how I would pronounce it. Ngozi needs to send out 300 wedding invitations. Let me underline that, 300 wedding invitations. In 1 minute, she can put 6 invitations into envelopes and apply stamps to them. It takes her a minimum of 50 seconds to address each invitation by hand. If N represents the number of invitations Ngozi could prepare for mailing in 180 minutes, which of the following inequalities best models the situation described above? So over here, you have 180 greater than or equal to something. It's in terms of N, in terms of the number of invitations. Is 180 greater than? This is 300 less than or equal to. This is 300 less than, right over here. Now remember what our constraint is here. Our constraint is how many can she prepare in 180 minutes? How many invitations can she prepare in 180 minutes? And so it feels like, and I haven't done the math here, that you're going to want one of them that deals with the 180. And since you can do it up to 180, that you would want not just the amount of time is less than 180, but it would have to be less than or equal to, or 180 doesn't just need to be greater than the amount of time. It could be greater than or equal to. As long as this is equal to 180, we are fine. So without doing any math, I'm already feeling that this right over here is going to be the answer. The 300, they're getting this from the fact that there's 300 wedding invitations, to make. Now, that is the absolute cap. That is the absolute cap on the total number of wedding invitations that she might be able to do. But that's not going to be, that's not the constraint that we're talking about. We're constraining her actual time here. So let's verify that we feel good about this. And it looks like they did everything in minutes. So let's do everything in minutes. So any one envelope. So let's see, in 1 minute, she can put 6 invitations into envelopes. So any one invitation, I guess I could say, how much will she spend time? How much time would she spend sticking it into an envelope and applying stamps? Well, she's going to spend 1/6 of a minute. So she's going to spend 1/6 of a minute. I'm going to do everything in minutes because these look like they're in minutes right over here. 1/6 of a minute putting any one invitation into an envelope and putting stamps on them. And then how much time will she spend writing the address? Well, she's going to spend 50 seconds to write the address for any one invitation. But if it's in terms of minutes, that's 50 out of 60 seconds in a minute. Or, so we could write this plus 5/6. 5/6 of a minute. And I'm really tempted to add these because they add up to 1 to 6/6, but it doesn't look like they added them over here. So I'm going to keep them like this. So this is how much time in minutes she would spend on any one invitation. And then if she's doing n invitations, well, this is per invitation, and then you multiply it by n, so times n. This is the total amount of time she would spend if she did n invitations. And so this thing right over here has to be less than or equal to 180. So we could write it like this. We could say less than or equal to 180, or we could say that 180, or we could write that 180 is going to be greater than or equal to that. And if you distribute the n, you're going to get this thing right over here. You're going to get 180 is greater than or equal to n over 6 plus 5n, actually, let me write it that way, plus 5 times n over 6, over the blue color, over 6, which is exactly what you have here. But it's really interesting because just looking at the choices, it actually jumped out pretty fast that this was probably going to be the one that we cared about. A line is graphed and the xy plane is shown. Which of the following equations represents the line? They give us a bunch of equations here. And so there's several ways we can tackle it. When we look at this, I can see there's two interesting points here. There's the point when x is, let me just write this, and actually let me write a little lower so we can look at it at the same time that I look at the equation choices. So we see that when x is 0, y is 1. So that is the y-intercept, we could say. And then when you could see when x is 6, y is 0. When x is 6, y is 0. So a very kind of basic way of approaching this is see like, well, when x is 0, y needs to be equal to 1. When x is 0, we get 6y is equal to 1. Well, then y is going to be equal to 1/6. Rule that one out. When x is equal to 0, y needs to be equal to 1. If x is 0, then 6y equals 6. Yeah, y is going to be equal to 1. Now, when y is 0, x needs to be equal to 6. So if y is 0, this goes away, and x is equal to 6. So we're done. This is our choice. Now, there's other ways that we could do it. We could write it first in slope-intercept form and then convert to this form right over here. So let's do it that way as well. So we could say that the equation of this line is going to be y, if I write it in y equals mx plus b form, where m is the slope and b is the y-intercept. We already know that b is equal to 1, so we already know that's 1. And what's the slope? Well, slope is our change in y for given change in x. And we see when our change in x is positive 6, when our change in x is positive 6, our change in y is negative 1. So our slope is we decrease in y by 1 when we increase in x by 6 is negative 1/6. So the equation of the line, y is equal to negative 1/6 x, this is the slope, plus 1. And then we could convert to the forms that we have here. So let's see, we could add 1/6 x to both sides, and you're going to get 1 over 6x plus y is equal to 1. And that's not quite what we have here. All the coefficients on x are just 1. So we could multiply both sides of this times 6, and we would get x plus 6y is equal to 6, which is exactly the choice that we picked. We're told the graph of the linear function f is shown in the xy plane above. We see that there. The graph of the linear function g, not shown, is perpendicular to the graph of f and passes through the point 1, negative 5. What is the value of g of negative 2? Pause this video and see if you could work through this before we do this together. All right. Now, one technique we can do is just try to figure out the equation of g. So we're going to have g of x is going to be in the form the slope times x plus the y-intercept. So first of all, let's think about what the slope is going to be. And if g is perpendicular to f, that means that g's slope is going to be the negative reciprocal of f's slope. So what is f's slope? Well, it looks like for every 3 we move to the right, we move up 1. Every 3 we move to the right, we move up 1. Or when the change in x is equal to 3, the change in y is equal to 1. We know that slope is change in y over change in x. So here the slope is 1/3. Let me write that down. If we were actually taking the SAT, you wouldn't write it down, take the time, but we might as well over here. Slope is equal to 1/3. So what's m going to be for g? Well, it's going to be the negative reciprocal of that. So we could say g of x is going to be the negative reciprocal of 1/3 is negative 3/1, or just negative 3x plus b. Now we need to figure out b. Well, luckily they give us a point over here, 1, negative 5. So we know that when x is equal to 1, so negative 3 times 1 plus b, then g of 1 is negative 5. So this is going to be equal to negative 5. And so we can solve for b. Negative 5 is equal to negative 3 plus b. And so we can add negative 3 to both sides, or sorry, we can add 3 to both sides, and we are going to get negative 2 is equal to b. Add 3 to both sides, this cancels, and then you get negative 2. And so now we know the equation for g. G of x is equal to negative 3x minus 2. And now we just go back and say, all right, then that means g of negative 2 is going to be negative 3 times negative 2 minus 2. Well, that is 6 minus 2, which is equal to 4. And we are done. Now, there's other ways that you could approach this. You could say if the slope of g is negative 3, and if we start at 1 comma negative 5, and we're trying to get to negative 2, let me write it this way. If we have x and g of x, and we know when x is 1, g of x is negative 5, and we want to figure out what about when x is equal to negative 2? Well, to go from 1 to negative 2, you need to subtract 3. So if the slope is negative 3, that means on this side right over here, negative 3 times negative 3, you're going to have to add 9. And so negative 5 plus 9 is 4. That's another way that you could have approached this. We're told Farah watched 2 different TV shows last week. TV show A has 11-minute episodes, and TV show B has 43-minute episodes. Together, she spent 196 minutes watching TV shows. Which equation models this relationship, where lowercase a is the number of TV show A episodes and lowercase b is the number of TV show B episodes Farah watched? So pause this video and have a go at it on your own before we work through this together. All right, now let's do this together. So we know that together she spent 196 minutes watching TV shows. So what we want to do is total the amount of time she spent watching TV show A, the amount of time she spent watching TV show B, and then that should be equal to 196. And so actually let me just do TV show A in this orange color. How much time did she spend watching TV show A? Well, we know that each episode of TV show A is 11 minutes. So it's going to be 11 minutes times the number of episodes. And they say that lowercase a is the number of TV show A episodes. So this right over here, 11a, is how much time she spent watching TV show A. And what about TV show B? Well, each episode is 43 minutes. So it's going to be 43 minutes per episode. And how many episodes are there of TV show B? Well, it's lowercase b is the number of TV show B episodes. So 43 minutes per episode times lowercase b episodes, that's how much time she spent watching TV show B. So if you add the amount of time she watched TV show A to the amount of time she spent watching TV show B, that will be her total time. And we know that that needs to be equal to 196. And so let's see which of these choices have it. That's not that one. Let's see, this one is it. Exactly what we got. This is different, and this is different, and we're done. Minli's house is located 1.4 miles from her school. When she walks home from school, it takes her an average of 24 minutes. Assuming that Minli walks at a constant rate, and we could figure that out because we know how far she walks in a certain amount of time, which of the following functions best models Minli's distance from home, d, in miles, so we want distance in miles, if she's walked a total of t minutes. So t is going to be in minutes, so all our units are going to be minutes and miles, and that's good because they gave us things in terms of minutes and miles. If this was in seconds or hours, we would have to do some conversion. So let's just think about her rate, her constant rate that they're talking about. The rate that Minli walks, well, she covers 1.4 miles. She covers 1.4 miles in 24 minutes. 24 minutes. Well, this isn't a pretty fraction with the decimal in the numerator, so let's multiply the numerator and the denominator by 10 so that we get rid of this decimal. So that's going to be equal to 14 over 240 miles per minute. And then we can further simplify that The numerator and the denominator are both divisible by 2. So this is going to be, let's see, 14 divided by 2 is 7. 240 divided by 2 over 120 miles per minute. Miles per minute. So we were able to figure out Minley's constant rate. Now we need to figure out D. We need to figure out D. So we have to be very careful. D is Minley's distance from home. From home. She's leaving from school, and it's her distance from home. Remember, her home is 1.4 miles from her school. So there's a bunch of ways that we can tackle it, but maybe the easiest one is, well, what's her distance? If you want to say distance from school, distance from school, that's just going to be her rate times t, times how much time has passed by. As when time is 0, she's going to be at her school. As time increases in minutes, she's going to get further and further away from her school. But her distance from home is going to be 1.4 miles minus the distance from school. So let me just write D, because this is what we care about. D, which is her distance in miles from home. Distance in miles from home. That's going to be 1.4 minus distance from school. Minus distance from school. And if that doesn't make sense, just think about it. If this is her home right over here, I'll write H for home. If this is her school right here, S for school, we know that this distance right over here is 1.4 miles. Now, if she has walked, say, I don't know, let me this in another color. If she has walked, I don't know, 0.4 miles, if this is 0.4 miles right over here, then her distance from home is going to be 1.4 miles minus that. It's going to be this distance right over here. So distance from home is going to be 1.4 minus the distance from school. And what's that going to be? Well, that's just going to be 1.4 minus the rate times the time. Well, what's the rate? 120, it's miles per minute. We got the units right. And so this is D is going to be equal to 1.4 minus 7 over 120 t. And if we look at the choices, that's going to be this first choice over here. And it's fun to look at the other choices and to think about, well, how could we have ruled them out fairly quickly? Well, this one has 1.4, the distance between the two places, minus 24t. Well, this isn't the rate right over here. That's how long it takes her to walk. It's not the rate. So you could rule that one out. This one is 1.4 minus the reciprocal of the rate. So that's a strange answer. And this one makes it look like she's getting further and further from home as time gets bigger. Notice this one right over here, it does correctly say at time 0, she's going to be 1.4 miles from her home, which is accurate because at time 0, she's going to be at her school. But then after 1 minute, after 2 minutes, after 3 minutes, she's going to get, based on this model, further and further away from her home. So this would be a case where she's walking away from home from her school. So you would rule that one out as well. Karunesh is a gym owner who wants to offer a full schedule of yoga and circuit training classes. Yoga classes are each 1.5 hours long, while circuit training classes are only an hour. And he wants at least 25 hours of classes, on the schedule each week. All of his instructors are paid $35 per class. So it doesn't matter whether it's an 1.5 hour yoga class or a 1 hour circuit training class. But Karunesh doesn't want to spend more than $1,000, does not want to spend more than $1,000 per week on salaries. Which of the following falls within Karunesh's guidelines for the weekly schedule? So we can just go through these choices. We can say, okay, which of these meet the at least 25 hours of classes, but then don't break the bank, don't cost more than $1,000. So this first one right over here, 3 yoga classes at 1.5 hours each. Well, this is going to be 4.5 hours here. Plus 19 hours, each circuit training class is an hour. So plus 19 hours is going to get you to 23.5 hours. So that doesn't get us to at least 25 hours of classes. So we can rule that out. Now see, 10 yoga classes and 12 circuit training classes. 10 yoga classes at 1.5 hours each, that's going to be 15 hours. Plus the 12 circuit training classes, that does get us to 27 hours. So it checks off the minimum number of hours that he wants to get. Now let's make sure it doesn't break the bank. So the classes are $35 per class, regardless of whether it's an hour and a half yoga class or it's a 1 hour circuit training class. So right over here, we're going to have a total of 10 plus 12. So there's going to be 22 classes times $35 per class. And what is this going to be? As I can already tell, it's going to be less than 1,000. And if you're under time pressure, you say, hey, this is less than 1,000. But if you want to verify that this right over here is less than 1,000, 2 times 35 is 70. And then 20 times 35 is 700. 700. So that's going to be 770. I know I did this in a somewhat non-traditional way. I could have done it like this. 35 times 22. So 2 times 35 is 70. 20 times 35 is 700. You add them together, you get 770. But the important point is this is less than $1,000. So this is going to meet our constraints. We have enough hours, but we haven't broken the bank. Now in these two, it looks like we have plenty of hours here. In fact, just the yoga class is enough meet our 25 hours, because 20 yoga classes is going to be 30 is going to be 30 hours of classes, and 25 is going to be even more. But I would suspect that these are going to break the bank. And if you look at this, is going to be 32 classes at $35 per class. Yep, that's gonna be over $1,000. And this one, I said this is going to be 31 classes, and so this is probably going to be over $1,000 as well. We're told Luis is cooking meals for at least 20 people. He estimates that the cost of each vegetarian meal is $3, and the cost of each meal with meat is $4.50. His budget for the meals is no more than $100, and he wants to cook at least 6 of each type of meal. Which of the following systems of inequalities represents the conditions described if X is the number of vegetarian meals and Y is the number of meals with meat Luis cooks? So pause this video and have a go at this yourself before we work through it together. And I know this is a long question and these systems feel complicated, but trust me, if you do it step by step, you'll actually find that it all falls into place. All right, now let's work through it together. And it's important to emphasize that they've already defined the 2 key variables for us. X is the number of vegetarian meals, and Y is the number of meals with meat. So let's look at each of the constraints they give us, and each of these can set up a different inequality. So the first one is they say Luis is cooking meals for at least 20 people. So that tells us that the total number of meals, which is going to be the number of vegetarian meals, that's X, plus the number of meat meals, that has to be at least equal to 20. So that has to be greater than or equal to 20. That's what that first sentence tells us. And if I wasn't doing this as a multiple choice, I would just keep adding more and more constraints here. But they give us some choices. And so we can see that X plus Y is greater than or equal to 20. That's in choice A. It's actually not in choice B. So we can already rule out choice B. They have less than or equal to 20 here. Same thing for choice C. So we can rule that out. And then choice D does have that. So we are still in the running. The next constraint they tell us, he estimates that the cost of each vegetarian meal is $3 and the cost of each meal with meat is $4.50. His budget for the meals is no more than $100. So how much is he going to spend in total? Well, on the vegetarian meals, he's going to spend the number of vegetarian meals times $3 per meal. So that's how much he's going to spend on vegetarian meals. And what about meat meals? Well, it's going to be Y meals times $4.50 per meal. So it's 4.5 times Y. The amount that he's spending on vegetarian meals, the amount that he's spending on non-vegetarian meals, that's the total he's spending on meals. And they say it is no more than $100. So this has to be less than or equal to 100. And so let's see. We actually, over here, we have 3x plus 4.5y is greater than or equal to 100. So we can rule choice A out as well. And just by deductive reasoning, we see choice D does have that in there, but this must be the answer. But let's keep going to make sure that these other constraints work. We are also told he wants to cook at least 6 types of each meal. So that means that X, the number of vegetarian meals, has to be greater than or equal to 6. And y, the number of non-vegetarian meals, also has to be greater than or equal to 6. And we see both of these down here. So we can feel pretty good about choice D. We're told the system of equations above has solution x comma y. What is the value of x? Pause this video and have a go at it before we work through it together. All right, now there's several ways that you could approach it, but the way I like to think about it right when I look at it is if in one of the equations I've already explicitly solved for a variable, so I have y is equal to 2x, well in the other equation I could substitute for that variable that has been solved for. So if y is equal to 2x, wherever I see y in the other equation, I can replace that. I can substitute that with a 2x. And then what does that give us? Well, this second equation here becomes 3x plus, instead of y, I can write 2x because I'm substituting. And then that is equal to 30. And then what's 3x plus 2x? Well, that of course is equal to 5x is equal to 30. I can divide both sides by 5, since that's the coefficient on the x term. And I get x is equal to 6. And I am done. Now, another way we could approach this is through elimination. If I subtract y from both sides of this top equation, I will get 0 is equal to 2x minus y. Or, of course, I could write that as 2x minus y is equal to 0. And then I'll rewrite this second equation, 3x plus y is equal to 30. And then notice, if I add the left-hand side to the left-hand side and the right-hand side to the right-hand side, the y's are going to cancel out. I'll get 2x plus 3x is 5x. Negative y plus y, that's 0y, they just cancel out. And then 0 plus 30 is equal to 30. And so we get back to the step, you solve for x, you get x equals 6 again. Consider the system of linear equations above. Which of the following choices of A will result in a system of equations with no solutions? No solutions. So a system has no solutions is if both lines, and these are both linear equations, they actually tell us these are linear equations, is if you have two lines that are parallel, then you have no solutions. They're never going to intersect. There's no XY pair that satisfies both of them. So if they are parallel, then you're going to have no solutions. So what makes two lines parallel? Well, if they have the same slope, but they have different y-intercepts, you're going to be parallel. So essentially, we need to pick the A here that makes the second line parallel to the first. And to do that, I'm actually write both of them in kind of the slope-intercept form, where y is equal to the slope times x plus the intercept. So let's do that. Let's do that for both of these. So first I'll do this one up here. So you have 9x minus 14y is equal to negative 3. See, if I subtract 9x from both sides, I would get negative 14y is equal to negative 9x minus 3. See, if I divide both sides by negative 14, I'm going to get y is equal to negative 9 divided by negative 14 is positive 9 over 14x, and then plus 3 over 14. So that's this line written in slope-intercept form. Now let me write the second line in slope-intercept form. So I have 2x minus ay is equal to negative 6. And let's see, if I subtract 2 from both sides, I get negative ay is equal to negative 2x. I'm subtracting 2x from both sides, so I get minus 2x minus 6. And then I can divide both sides by negative a, and I get y is equal to negative 2 divided by negative a is positive 2 over ax, and then plus 6 over a. All right. So we need to set up a situation. Where 2 over a is equal to 9 over 14. These two things have to have the same slope. And then when we're able to figure out that a, we have to verify that they have different y-intercepts, because if they have the same slope and the same y-intercept, instead of having no solutions, they would have an infinite number of solutions, because then it would be the same line. But let's solve for a. So we know that 9 over 14 needs to be equal to 2 over a. 2 over a. Or another way of thinking about this, we could take, there's just a bunch of, sometimes people say cross multiplying and all of that. I like to just do a bit, logical algebraic operations. But we can take the reciprocal of both sides. So we could have, and actually let me swap both sides. So we can say a over 2 is equal to 14 over 9, is equal to 14 over 9. And then multiply both sides by 2. Multiply both sides by 2. And you're going to get a is equal to 28 over 9. A is going to be this right over here. This is 28 over 9. So if I'm under time pressure, I already see a choice that's looking pretty good. But if we really want to care that, okay, if a is 28 over 9, these two things are going to have the same slope. But let's make sure they don't have the same y-intercept. And I wouldn't do this if I was under time pressure, but just to feel good about it. If this y-intercept is 6 over a, so it's going to be 6 over 28 over 9, which is 6 divided by a fraction is the same thing. It's not dividing by a fraction, the same thing as multiplying by its reciprocal. So it's going to be the same thing as 6 times 9 over 28. And this is going to be equal to 6 times 9 is 54 over 28, which is clearly different than 3 over 14. So if a is 28 over 9, same slope, different y-intercepts, and you're dealing with parallel lines. They will not intersect, and you're going to have no solutions. We're told that Hazel and Leo are comparing the number of keys on their keychains. If Leo has 4 more keys on his keychain than Hazel does on hers, and the two of them have 18 keys combined, how many keys does Hazel have on her keychain? So pause this video and see if you can figure that out. Okay, now let's do it together. So there's two things that we don't know here. We don't know how many keys Hazel has on her keychain, and that's what they're asking us for. But we also don't know how many keys Leo has on his keychain. And they give us 2 pieces of information. Leo has 4 more keys on his keychain than Hazel, and that the two of them have 18 keys combined. So it's feeling like we can set up 2 equations with 2 unknowns. If we let L be equal to the number of keys Leo has, I'll just say for Leo, and then H equal to the number of keys for Hazel. And obviously, if you were doing this on a test like the SAT, you wouldn't have to write all of this out. You would trying to be getting to the solution, but I'm trying to explain it out for you, so I will do that. And so let's see how we can set up these 2 constraints that they gave us as equations. So it says if Leo has 4 more keys on his keychain than Hazel does. So how could we write that mathematically? So Leo has 4 more keys on his keychain than Hazel. So we could write that Leo is equal to the number of keys that Leo has is 4 more than the number Hazel has. So it's Hazel plus 4. So we could write it like that. We could also write it that the difference between the number of keys Leo has and the number of keys Hazel has is 4. So another alternative, we could have written it like this. Leo minus Hazel is equal to 4. And these are algebraically equivalent. It doesn't take much manipulation to go from one to the other. But that's ways that we can mathematically write that first sentence. And now what about that second one? And the two of them have 18 keys combined. Well, that just means that L plus H is equal to 18. So we could just write it that way. L plus H is equal to 18. I could write it like that again. L plus H is equal to 18. And obviously there's other ways that you could mathematically write this or that would be equivalent to this. But now in either case now, we have 2 equations with 2 unknowns. And there's 2 ways that we could go about approaching them. When I look at this version, this system of equations right over here on the left, where I've already solved for L, to me, this feels like substitution might be really valuable. Because I have an L here, and we know that L is equal to H plus 4. So if I substitute H plus 4 in for L, then I have one equation with one unknown. If L is equal to H plus 4, I get H plus 4 plus H is equal to 18. And then if I add the H's, I get 2H plus 4 is equal to 18. And let me scroll down a little bit. And then if I subtract 4 from both sides, and remember I'm doing that to isolate the h's on one side of the equation, well then I'm going to get 2h is equal to 14. And then dividing both sides by 2 gives me h is equal to 7. And we could then use that information to say, okay, L is equal to h plus 4, so it's 7 plus 4 is equal to 11. But they're not even asking us for the number of keys Leo has. They're just asking us for the number of keys Hazel has on her keychain. And we just figured that out. Hazel has 7 keys. Now, we could go to this other system and we could have solved this one as well. And here, it feels like elimination would be the more natural method. The reason why it jumps out at me that elimination would be the natural method, we have a negative h here and we have a positive h there. Now, one issue to think about, and there's many ways to solve these, is if we just add the left-hand sides of this equation and add the right-hand sides of this equation, then we're going to get an equation in terms of L because the h's will cancel out. So then we would solve for L and then use one of these equations to figure out h. Another way that you could do it is you could multiply one of these equations by a -1 on both sides. And then when you do the elimination, it would eliminate the L immediately. And so let's try it out that way. So let's multiply this top equation by -1 on both sides. So -1 times L is negative L. -1 times a negative h is positive h. And then this would become a -4. And now when we add the left-hand sides, negative L plus L cancels out. H plus h is 2h. And that's going to be equal to -4 plus 18, which is 14. And then divide both sides by 2. And we get, once again, h is equal to 7. You could have very easily done it the other way. You could have said L minus h is equal to 4, and that L plus h is equal to 18, and then immediately just add the two sides of the equation. On the left-hand side, those would cancel out. You would get 2L is equal to 22. Divide both sides by 2. You would have gotten L is equal to 11. But remember, they don't ask us about Leo. They're asking us about Hazel. So then we would have to substitute that back into one of these equations to figure out that h is equal to 7. Tickets for a play were $2 for each child, $4 for each adult. At one showing of the play, one adult brought 4 children, and the remaining adults brought 2 children each. The total ticket sales from the children and adults was $60. How many children and adults attended the play? All right, this is an interesting one. Okay, so let's just think about how much was spent at the play. I mean, we know it has to add up to $60, but let's think about it in terms of the children and adults and their admissions. So you have this one adult right over here that brought 4 children. So how much is that adult? How much is this family? Let's just assume it's a family. How much are they going to spend? Well, that one adult is going to spend $4 for their own ticket, and then 4 children at $2 each. So plus 4 children times $2 per child. This is going to be $8 on the children's tickets plus $4 on theirs. They're going to spend $12. So that adult is going to spend $12. And then there's some remaining number of adults that brought 2 children. So let's set some R is, I could say the remaining number of adults, or the number, let's say adults with 2 children. Adults with 2 children, that's R. So each of these adults with 2 children, how much are they going to spend? Well, they're each going to spend $4 on their own ticket for the adult, and then they're going to have 2 children at $2 each. So they're going to spend $4 on the children's tickets. So they're going to spend $8 in total. So each of these adults with 2 children are going to spend $8 at the play. And there's R of them. So they're going to spend $8 for each of these adults with 2 children, and there are R of them. So this is a total amount of ticket sales from the adults with 2 children. And you add that to the ticket sales from this one adult with the 4 children, and they're going to have to add up to $60. So this is going to have to add up to $60. Let's see, we can subtract 12 from both sides, and then on the left we'll be left with 8R. Is equal to 60 minus 12 is 48. Divide both sides by 8, you get R is equal to 6. So we want to be very careful. You might say, oh, okay, there were 6 adults. These are just the adults with 2 children. There's 6 adults with 2 children. How many? But there's another adult. There's another adult who brought 4 children. So there's a total of 7 adults. 7 adults total. Pardon my handwriting. 7 adults total. So we could just look at these choices. Only one of these choices have 7 adults. And we could verify that this would also amount to 16 children, because this person up here in magenta, they would bring 4 children. So you'd have 4 children plus 6 adults brought 2 children. So that 6 adults bringing 2 children each, that would amount to 12 children. And that indeed does add up to be 16. But if you're under time pressure, you can see, look, there's only one choice that has 7 adults, so you could just pick that one. The value of a bond on January 1st, 2014 is $1,000. Each year, the value of the bond increases linearly by $75. So after 1 year, it's going to be $1,075. After another year, it's going to be $1,150, so on and so forth. Which graph below represents V, the dollar value of the bond, as a function of T, the number of years after January 1st, 2014? Well, there's a couple ways to think about it. What's the value of the bond when T equals 0? When T equals 0, that means that we are at January 1st, 2014. We are no years after January 1st, 2014. So when T equals 0, we should get the $1,000 value of our bond. So let's see, this choice has that. At T equals 0, our bond is worth $1,000. This one at T equals 0, I don't know, it doesn't even I don't even see what the value of the bond is. So I would rule this one out. This one at T equals 0, the value of our bond is $1,000. This one at T equals 0, our value of a bond is $500. So I would rule this one out as well. So the two that we're left with, this one and this one, they start in the right place, but let's see how fast they increase. So remember, every year we should be increasing by $75, or you could say every 2 years we should be increasing by $150, or every 3 years we should be increasing by $225. So let's see. Here, I'm just going to try to eyeball. Let's see, after 2 years, we should increase by about $150. And that doesn't look inconsistent because one whole block in the vertical axis is $500. So let's think after 3 years, we should be $225. We should be, so that actually looks a little bit less than little less than half of 500. So this one is looking pretty good. Let's look at this choice right over here. This one's actually a little bit clearer. It looks like in 2 years, we've increased almost $500, which means we're increasing nearly $250 per year. You see that in 1 year, it looks like we've increased by more than $200. So this one is increasing too fast. We ruled this one out, and this one looks close enough. It looks like it's consistent with $75 increase per year. And once again, we're just eyeballing it, but it looks pretty good. And this one is way off, and these two just started in the wrong place. So I would definitely go with this one. A college bookstore charges $60 for a yearly membership. The first book is free with the membership, and any book after that costs $7.60, including tax. How much money M does a student spend after buying B books and a yearly membership? So M, the amount of money that they're going to spend, it's going to be the yearly membership, which is $60. So we're going to do everything in dollars, $60, plus the amount that they spend on books. So they're going to buy B books, and it's $7.60 per book. So it might be tempting to say, all right, I'm going to do $7.60 per book, and then multiply that times B books. So this right over here might be very tempting. We have to remember something. The first book is free. The first book is free. So if you buy one book, you're not going to pay $7.60. You're going to pay nothing. If you buy 2 books, you're not going to pay $14.20. You're only going to pay $7.60. So you're only going to pay for one less than the number of books you buy. So instead of $7.60 being times the number of books, it'd be $7.60 times one less than the number of books you buy. One way to think about it is this B minus 1, you could think of this as books you need to pay for. Books that are not free, I guess. Books that are not free. The first book is free, and every one after that you would pay for. And this makes sense. If B is 2 minus 1, you're going to pay for 1 book. If B is 10, that means you're only going to have to pay for 9 books. 9 times $7.60 plus the membership. All right, now let's see which of these choices actually match what we just wrote. So this one doesn't include the membership and doesn't take 1 from the B to account for the free book. This one over here does account. It does account for the free book, but it doesn't account for the membership, so you don't want to do that. This one accounts for the membership, but it doesn't account for the free book. And then we have this one here, which is exactly what we wrote, except they just swapped. If you just swap these two terms, if you do $7.60 times B minus 1 plus 60. So we're going to go with that one right there. Y is equal to 3x, x is equal to 3y. Consider the system of equations above. How many solutions does this system have? Well, when I think about solutions to systems, I always imagine each of the equations in our system is kind of describing a line. And if the two lines intersect, you're going to have one solution. And if they don't intersect, you're going to have no solutions. And if they end up being the same line, you have an infinite number of solutions. So let's see. And so we can immediately rule out, because these are linear equations, two solutions. The only way you're going to have two solutions is if one of these lines, at least one of them curved. So if one of them did something like this, then you could have two solutions right there and right there. But these are both linear equations, so we can rule out having two solutions. But let's just think about these up here. Well, what I like to do is let's solve them both explicitly for y. That's at least how I like to visualize lines. This first one up here is already written explicitly in terms of y. The second one over here, let's divide both sides by 3. And we get y is equal to x over 3. So this first one is y is equal to 3x. The second one is y is equal to x over 3, or we could say 1/3 x. And so these lines, they don't have the same slope. So they're not going to be parallel, and they're not going to be the same line. So these are going to intersect. These are going to have one solution, exactly one solution. And if you wanted to visualize this on the coordinate axes, I'll do it really fast. If that's our y-axis, this is our x-axis, x, y. This first line right over here, this is going to have a slope of 3. So it's going to be a pretty steep line. It's going to look something like this. And then the second line right over here is going to have a slope of 1/3. So it's going to look something like this. These two clearly intersect. And actually, now that I look at it, one way to realize that you're going to have at least one solution, and then you'll see it, and you even see it where they're intersecting right over here. The solution is when x and y both are equal to 0. But since you want to rule out that, hey, maybe it has an infinitely many solutions, just think about what these lines represent. This first one, very steep line right over here. The second one, a much less steep line, but they're different lines, so they're not the same line, and they don't have the same slope, so they're not going to be parallel. So they're going to intersect in exactly one point.